Hello everyone. Now we are going to discuss about topic in transmission and RF systems, unit number 4, wavegates, and this is the syllabus. And we will discuss about the first topic as electromagnetic waves between parallel plates. Right, electromagnetic waves between parallel plates, and the electromagnetic waves that are guided along over a conducting or dielectric surface is called as guided waves. Right? These EMA waves are guided along the conducting surface or dielectric medium. It is called considered as guided waves. And we are going to consider about a parallel plate of two plates. Right? Consider an electromagnetic wave propagating between a parallel plate. It is extended in a y direction and z direction. So, right? We have to consider about this. And this is the parallel plate. This one is on first parallel plate, this one is second parallel plate. This is placed in a horizontal axis. It is extended towards in a z direction and also x direction, right? And so to find out the solutions, right, we have to find out the electromagnetic fields. So for that we are going to use the Maxwell solutions. Maxwell equations will be used to determine the electromagnetic fields. And the Maxwell equation for non-conducting medium rectangular region is given as del cross H is equal to j omega epsilon E, and del cross E is equal to minus j omega mu H. And we can write the value of del cross H, which is called equation modulus of AX, AY, AZ, dou by dou X, dou by dou Y, dou by dou Z, HX, HY, HZ. And we can find the value of determination value AX is equal to AX into dou Y by dou by dou y into hz minus dou hy by dou z. And similarly we can write the three values, and we can equate the this value with respect to this equation j omega epsilon e in terms of ex, ey, ez, and ax, ay, az are unit vectors. And we can equate the left hand side, right hand side components. Left hand side we have del cross H, right hand side we have j omega epsilon e, ax, ex, ay, ey, az, ez. So this is left hand side, that's going to be right hand side. We can equate the values in terms of dou by dou hz, dou hz by dou y minus dou hz dash by dou z is equal to minus j omega epsilon ex. Similarly we can equate the three values, and this is considered equation number 1. And similarly we can write the value for del cross E, the same method, matrix of ax, ay, z, dou by dou x, dou by dou y, dou by dou z. And similarly we have ex, ey, ez. Here we have e, and here we have ex, ey, ez. And similarly we can equate the determinant value. Here also we can equate the x, y, z components of both sides, and this will be considered equation number 1. Dou ez by dou y minus dou ey by dou z is equal to minus j omega mu hx. The first component belongs to first this ax unit vector. So this is the first component equation, this is the second component equation, and this is the third component equation. And how we can find out the solution here. And this is the wave equation, del square E by is equal to gamma square E, del square H is equal to gamma square H. And we can write that gamma square in terms of sigma into sigma plus j omega epsilon into j omega mu. We can write the value for non-conducting medium. It becomes the value del square E is equal to minus omega square mu epsilon into E, and del square H is equal to minus omega square mu epsilon into H. And left hand side we can expand the value, right? Dou square E by dou x square plus dou square E by dou x square plus dou square E by dou z square is equal to minus omega square mu epsilon E. And similarly we can write the values of H. This is equation number 3. And we can assume that the propagation is in the x direction only, and in this direction it must be expressed in terms of e to the power of minus gamma z, because the direction of propagation is the direction, so the waves are exponentially decaying, so it will be represented in terms of e to the power of minus gamma z. And gamma is the propagation constant, which is given as alpha is alpha plus j beta. Already we know if alpha is equal to 0, we propagate with attenuation. Attenuation is 0 means there is no attenuation, and if alpha is real we have no propagation. If we have some real value means there will be some attenuation. So we can substitute value h is equal to hy naught e to the power of minus gamma z, and dou by we differentiate this equation with respect to z, and this is the constant value hy substitute naught, the value will come e to the power of minus gamma z. If we want to differentiate this term, we have minus gamma into e to the minus gamma z. So this entire value will be placed in terms of hy, so minus gamma into hy. Similarly we can do it for hz, and we can equate the value ey equal to ey naught d2 minus gamma z, dy is the value. Similarly you can find the three values, right? So in the above equation already we told that there is no variation in the y direction, so the derivative of y is always 0, and you can substitute the z derivative values and y derivative in equation number above three equations. And if you are going to substitute y derivative value is equal to 0, means you have gamma and hy is equal to j omega epsilon ex, and hx dou hz by dou x is equal to j omega e epsilon ey, and dou hy by dou z is equal to j omega epsilon ez. It is nothing but divided by dou y means the value will be 0, that is the derivative value will be 0. So dou y means that the value will be 0. Similarly for remaining three equations, and similarly for wave equations also, right? So this is the three set of equations we have, and already we know in this equation dou square e by dou x square is equal to gamma square e, and dou square e by x is equal to gamma square h. And from these equations we are going to find out the hx, hy, ex, ey values. And first you have to find out the value of hx. So consider this equation, gamma minus gamma into hx minus dou hz by dou x is equal to j omega epsilon ey. Do the simplification, just rearrange the equation. This j omega simply we can consider the two equations. From the above two equations we are going to write the value. Hx is equal to, right, minus j omega mu, this minus gamma into ey divided by j omega mu. From this equation ey is equal to 1 by j omega mu, this value, and this ey value will be substituted here, and hx is equal to minus j omega gamma into j omega mu into, we have substitute the entire value of the ey here. And similarly for hx, just rearrange the values here. Hx value will be comes into one side, and remaining values comes inside, and take the LCM value here, and the denominator value goes into right hand side. We can cancel the denominator value, and we can find the value hx is equal to this value. Similarly we can write the value. So here omega square mu epsilon plus gamma square will be represented as h square. Similarly you can find the value of hy. The same steps will be followed here also. Simple derivation, and the third one, to solve for ex, gamma into ex plus the gamma and dou ez by dou x is equal to j omega mu hy. From the fifth equation we will take this equation, and from fourth equation we will consider this equation, and you can substitute the value of hy in this equation here. Do the simplification, this is the equation, and we will get ey also. A simple derivation, we will get it. So this is the final value. We have hx, hy, ex, ey. Four values we have derived. Thank you.